Hello everyone. In this video, I'm going to provide an introduction to data cleaning, which is a super common task in data science. In fact, it's super common because this is the task that data scientists report they spend the most amount of time on. Often our data sets are not in a form that is ready for analysis or machine learning or visualization or data mining or whatever we have planned for the data. So we have to spend a little bit of time, sometimes a lot of bit of time, in order to get it in that format that we need for further analysis. Real briefly before we get started with our demo, I have a diagram here showing what data scientists spend the most time doing, and that big green ring on the left there showing 60%, that corresponds to cleaning and organizing data. So more generally, data preparation. Examples of what constitutes data preparation includes, but is not limited to, tasks such as loading data into an appropriate data structure, merging multiple data sets, perhaps doing something called a table join to join two data sets or two tables on a common attribute or set of attributes, cleaning the data, and depending on your data set, there might be very few things to clean or a lot of things to clean. This could include reshaping the data, transforming the data, changing data type, replacing values, removing duplicates, performing data binning or discretization, handling missing values, detecting outliers, and standardizing and scaling data. And this is not a comprehensive list, just a list of some examples of data preparation and data cleaning. Now that we have an overview of the importance of data cleaning and data preparation, let's head over to our demo. In this video, I'm going to use real-world data as part of the data cleaning demo. The data that we're going to be working with is called pd_hoa_activities.csv. And I'll put a link in the description of this video for where you can download this data if you want to follow along with the video, write Python code, and exercise your Pandas abilities. So PD stands for Parkinson's disease, and HOA stands for healthy older adult. And this data is part of the data that's used in a published research article that's published in the IEEE Journal of Biomedical and Health Informatics, which is available on IEEE Explore. The article you can see here is called Analyzing Activity, Behavior, and Movement in a Naturalistic Environment Using Smart Home Techniques. And the purpose of the study was to compare how two different groups of people perform tasks which correspond to what are known as activities of daily living, or things that we do commonly in the home. So the two groups are healthy older adults and folks with Parkinson's disease. So if we look at the data here, the first row is what's called the header row, and it has all of the column names. So there are 5 column names, PID or participant ID, which is just counting numbers starting from 0 to 1 to 2 to 3, etc. And then next, we have task, which is an integer ID representing the task. It's either 1, 2, 3, 4, 5, 6, 7, or 8, or DOT, where DOT corresponds to the day out task, and then 1 through 8 correspond to various other tasks. For example, 1 corresponds to water plants, 2 corresponds to fill medication dispenser, and then another example would be 5, which corresponds to cooking. Next, we have duration. So duration is an integer representing the number of seconds it took the participant to perform the task. So for example, if we're looking at line number 2 in this file, which is the first data row, participant 0 completed the first task in 146 seconds. And then next, we have the age column. So this participant was 72 years old. And then we have the class column, which represents which group did this person belong to. Did they belong to the healthy older adults group or the Parkinson's group? So if we scroll through a few of these lines, we see some repeat data because each line represents a task performance, but each line has a repeated participant ID, age, and class. So the first 9 data lines all correspond to participant 0 and their 9 task durations. And then the next 9 lines correspond to the next participant, participant 1, who was also a healthy older adult. But if you look at how their class is encoded, it's in all lowercase, whereas the previous participant's class was encoded in all uppercase. So there's already a discrepancy here about how whoever inputted the data chose to input the data, right? What format did they use? And the next participant number 2, the third one, was a Parkinson's participant. And then the next participant, ID 3, was also Parkinson's participant, but now we have a not so subtle difference in how the Parkinson's class was encoded, right? Here it's spelled out, but here an acronym is used. So initially, right off the bat, we can see that this class column needs some cleaning so that we have more consistent labels, right? If there's only two possible class labels, HOA and PD, and we can essentially clean this column so that every single row in this column has a value of HOA or PD when we do analysis like, say, group by, and we want to group all of the rows in the table by class, we can get two nice data frames that are consistently all HOA and consistently all Parkinson's disease, which can make some data aggregation much easier and much more accurate. If I keep scrolling, looks like everything looks good so far. There could be some missing values, for which missing values are denoted in numerous ways. That's part of doing your research and getting familiar with your data, is figuring out, well, how are missing values encoded in this data set? Sometimes they're truly missing. Like, for example, let's say this task duration was gone, in which case I might just see two commas right next to each other because there's no value. I'll undo that. But I'll let you know how missing values are denoted in this data set. It's not truly with missing values. It's not with NA or NaN. It's actually with question marks. So if I search for a question mark, I see that not until line 215, participant ID 23, do we have a missing task duration. So for whatever reason, the task number 7 and 8, which correspond to 7 is a timed up and go test, and then 8 is the timed up and go test with questions being asked, do we have some missing values? We don't know the durations here. So we'll talk a little bit about how we might go about handling these missing values, because if we wanted to, say, compute the average task duration over all the participants, our arithmetic would actually error out, because as we're summing all of these integer values, we can't sum 22 plus question mark. So we do need to do some cleaning for sure with the duration column. Now, the only other thing I'll mention that we need to do to clean up this CSV file that isn't necessarily cleaning, but it will be really helpful for future analysis, would be to encode, or maybe I should say decode, these task numbers 1, 2, 3, 4, 5, 6, 7, 8 DOT to something more human readable. Like, for example, the fact that I just said 7 and 8 are related to something called the timed up and go test is not clear just looking at these numbers, right? I would need another file which would show the mapping of, say, 7 to timed up and go in order to figure that out. So we'll do that as well. It's a fun exercise in Python, and it is a data cleaning task, though maybe not a necessary one, but definitely a helpful one as we start to explore our data. All right, so let's get started. Let's make a new Python file. I'll call it main.py. And note that I'm making this in the same folder that contains my CSV file so that I can use a relative path to open main.py. There's two libraries that we're going to use in this demo. They're both common data science libraries in Python. The first one is NumPy, and the second one is Pandas. I'll provide some comments throughout our code here in order to kind of guide you through what we're doing and where we're doing it. So the first thing we need to do is we need to load this data from the CSV file into a data structure in Python so that we can start doing some operations on it. And the data structure of choice we're going to use is a Pandas data frame, which is a really nice 2D data structure that supports label-based indexing, and it has a lot of built-in functionality for working with data, such as handling and working with missing values, which will be helpful for what we're going to do today. So I'm going to call pd.readcsv, and I'm going to pass in the name of the file we're going to open, which is pd_HOA_activities.csv. Just to make sure everything goes well, I'll print out df.shape, which will tell me the dimensions of the data frame. So how many rows are there and how many columns are there? So looking at the output down here, it looks like everything went well. If you have an error related to file not found, double check that the name of your file is correct, and then double check that that file is in the same folder as the Python script from which you're trying to open it. So if we look at the shape down here, we see that there are 675 rows in the data frame and 5 columns. So let's go back to pdhoaactivities.csv and scroll down to the bottom of the file. Looks like there are 676 lines. So the fact that there's one fewer in the data frame is because the default implementation of read CSV is to try and infer a header row from the first row of the file. And in fact, we do have a header row at the first row of the file. So that's probably why we have one fewer row in our data frame, because the first row was inferred as the header row, which is awesome. That's what we want. If your header row is not the first row, you can always pass in header is assigned and then specify a row number. This will work exactly the same because, like I said, the header row was automatically being inferred by Pandas. In fact, I'm going to confirm that. What I'm going to do is I'm going to add a section here to explore the data. So, for example, I'm going to print out df.head passing in 5. So what this will do is print out the first 5 rows of the data frame. I don't want to print out all 675 rows because that's going to be a lot of output to scroll through. In fact, I'd rather just scroll through that in the CSV file or open the CSV file up in Excel, because then all of the rows will be nicely organized and I have all the Excel features to work with. Anyways, so here's our output down here. Here are the first 5 rows. So it looks like awesome. We have PID, task, duration, age, and class. I didn't specify an index column when I read in the CSV file because if you look at the CSV file, there actually isn't a unique identifier for each row, aka a key. So I just wanted a default kind of row number count to be used as the index in the data frame. And that's the default behavior we get if we don't pass in index column to read CSV. So we just get this nice default counting index here, 0, 1, 2, 3, 4, all the way up to 674, one less than the number of rows in the data frame because of zero-based indexing. So this looks really nice here. I might be interested in looking at the end of the data frame. So that would be print df.tail. And let's say I just want 5 rows at the end. So here are the 5 rows at the end. 670 to 674 are the last 5 row indexes. And it looks like our highest participant ID here is 74. Now I might be curious, well, how many total participants are there? Well, recall that there are 9 tasks. So if I were to say take the number of rows and integer divide by 9, then that would tell me the number of participants. So let's do that. So this would be df.shape sub 0, the number of rows, and then integer divide by 9, where 9 is the number of tasks per participant ID. So let's see how many we have to work with. Looks like we have 75, which makes sense since the highest participant ID number that we encountered was 74 with zero-based indexing, as our head output confirms, that would be 75 participants. So I'm kind of just doing some spot checking here to make sure that logically the data seems to be stored in the data frame the way I think it is. And I'm also trying to sense if there's any missing values, right? Like, for example, if the number of participants ended up being like 60, but my highest participant ID number is 74, then I might be a little bit suspicious if perhaps there are some missing participant IDs in here. All right, like I showed earlier in the CSV file, there are some missing values in here. For example, if I look at lines 215 and 216, I'll see those missing values here. Let's also print these out using slices on the data frame just to confirm that they're there when we read them into the data frame. So all I'm going to do now is essentially print out a slice of the data frame, which is also nice to show you how you can do this. So I'll do df.ilock, ilock because I'm taking an integer, an index-based slice. So let's do lines, say, 660 to 670. I checked in advance and these correspond to indexes in the data frame that have some missing values. And then I'm going to do comma and then a colon to grab all of the columns. Here are some right here corresponding to participant 73. We have missing durations for 7, 8, and day out task. Now let's move on to how can we handle these missing values? We know they're there. We know that they're encoded as question marks. What can we do? Well, let's take a little moment and talk a little bit about missing data. So first off, it is not uncommon to have data sets with missing values. Missing values are usually encoded as some kind of out of range value. For example, a question mark is definitely out of range for an integer column that records the number of seconds. -1 would also be out of range, right? You can't have a -1 for a duration for a task. So really, it's up to whoever is entering in the values. This could be researchers. This could also be a program, right? If the data is maybe coming from a form and being inputted into a database, and then you're getting a dump of that database or an export of that database, right? So you might not have control over how the missing values are encoded. But what you do have control over is doing research into each attribute. What kind of attribute does it represent? What is its appropriate data type? What would be in range? What would be out of range? And then trying to identify the missing values and handle them accordingly from there. So what we're going to do is we're going to take a look at this duration column specifically and see just how many question marks are there, because we're just getting familiar with the data. And we also want to know, is it okay if we just remove rows with missing values? Is it small enough that that would be safe to do? You know, if our data set was small, we wouldn't want to just start throwing away rows with missing values. But if our data set was really large and the number of missing data rows is small, then that might be safe to do. So let's see what we're working with here. I'm going to print out df sub duration. So this will give me what's called a Pandas series, which is a one-dimensional data structure, right? One column in a table represents a one-dimensional list of values. And then I'll call this really handy method called value counts, which is going to return each value in the series and how many occurrences of that value there are. I'm only interested in the value question mark, so I'm going to index using the question mark key to get its value. How many occurrences are there? So it looks like there are 10. There are 10 missing duration values. So I'm talking about 675 rows here. So 10's not so bad. So I do feel okay for this demo getting rid of those rows that have missing values. So real quickly here, ways to handle missing values. The first one is to discard them, which is what we're going to do in this video. I'll just emphasize again that we never want to throw away data. If our data set is large and the amount of missing data is small, then it's probably okay to throw it away. But if your data set is small, which is relative to your problem you're trying to solve, you may or may not feel comfortable throwing away that data, especially if that data was really, really expensive to collect. If we're missing one value in a column and maybe there's like 10 columns, then we probably don't want to throw away the entire row. So keep that in mind. And then number two would be to fill the missing values. And there are quite a few ways to do this. For example, with a categorical variable, you might choose to fill the missing values with, say, the most frequent label. You might also choose for a numeric or a continuous attribute to fill with, say, a central tendency measure. So this could be something like filling with the mean or filling with the median, filling with the mode. Or you might even do a little bit more intelligent filling, such as, well, I'm going to only fill this missing value with the 5 nearest rows missing value central tendency measure, like average. That way you're doing a little bit more of an intelligent base fill. We're not going to do any filling in this video. We're going to do option number 1, discarding. But I will mention when we do the discarding how you can do filling if you're interested. Now let's do approach number 1, discard these 10 rows that have missing duration values. The first thing that we're going to do is we're going to replace the question marks with np.nan. np.nan is a special value in the NumPy/SciPy ecosystem, which stands for not a number. And in this ecosystem, nan is used to denote missing value. A missing value decoded as nan is really, really nice because there is support in the SciPy libraries to handle nan specifically. For example, the Pandas function is null will return a Boolean array detecting the NaN values element-wise inside of, say, a series or a data frame, and drop NA will remove NaN values from a series or data frame, supporting approach number 1 to missing data. There's also fill NA, which will be used to fill missing values using a certain strategy or approach, and that supports approach number 2, which is to fill missing values. So let's do this. I'm going to call df.replace. So this is a data frame method that accepts a value to search for in the data frame, a value to replace all occurrences of that value in the data frame with, and then I'm going to pass in place is true so that this is done in place, meaning this is going to modify the data frame in memory instead of returning a copy. If I didn't have in place is assigned true, then on the left-hand side of this call over here, I'd have to have an assignment to save or overwrite my data frame with this return copy with all the question marks replaced with np.nan. So now what I'm going to do is I'm going to print out df.isNull.sum, and I'm going to see how many null values there are in the data frame. As I mentioned earlier, isNull is a method in Pandas that is going to return a Boolean array representing true or false if this value in a data frame or series is null or not, meaning np.nan. And then sum is going to sum over all of the trues and count them up column-wise. So my output here is actually a Pandas series. It's got 5 key value pairs in there, 1 for each one of the attributes. So we can see there are 0 nulls in the PID, the PID column, 0 in the task, but 10 in duration. So awesome. This is what we know, right? We knew there were 10 question marks, and now I've converted those 10 question marks into this special value np.nan, which allows us to start working with standard missing value functionality that's included with Pandas, such as detecting missing values and counting missing values. And now, if we're doing approach number 1, dropping missing values with drop NA, or if we're doing approach number 2, filling missing values with fill NA. So we're going to do the drop NA approach. So what we're going to do is we're going to do df.dropNA. I'm going to pass in, once again, in place is true. And now I'm going to call this df.isNull.sum again. I'll put a nice little label on this time. So I'll say after dropping. And I should have 0 for all of my columns. And it looks like I do. So this is awesome. So those 10 rows that had missing duration values, they're now gone. I'll also confirm this by printing out df.shape. Recall that I had 675 rows. I should now have 665 rows. And I do. The only thing I need to be concerned about with dropping rows is now my index is not truly counting one at a time, 0, 1, 2, 3. There's going to be some rows that are just going to jump. For example, if we scroll up, looking at, say, rows 663, 664, and 665, if I remove these 3, then whatever was before, it might be 662 or it might be something else if we drop rows before, is going to just jump by 3 to the next index. So I'm going to show you how you can reset your index after you've dropped some rows so that it's still counting from 0, 1, 2, 3, etc. That way, if you do anything that uses the index, say as slicing or selecting, you don't get some weird logic errors later that are really difficult to hunt down. So let's do df.resetIndex. We'll pass in place is true. And then I'm going to print out the data frame. We'll just do a few rows, like, I don't know, the first 2, just so we can see the column headers, because this is actually going to save the old index, which in some cases is what you want, but in other cases it's not what you want. So here's that old index saved. If you don't want that old index saved, then do drop is true, and it'll drop the old index and then set the new index. So now our index is back to counting numbers 0, 1, 2, 3, etc., which is exactly what we want. So cool, it looks like we have successfully handled our missing data. Remember, the options are to discard them, fill them, or even an unofficial third option here would be do nothing with them and then just handle them on a case-by-case basis later. That one's kind of tricky because you have to remember that they're there and then handle them appropriately. All right, let's move on to some additional data cleaning tasks. I talked earlier about how this task column has an integer 1, 2, 3, 4, 5, 6, 7, 8 and DOT, which isn't very informative for what the task represents. So let's do a fun little activity here where we are essentially going to decode the task attribute. So we're going to replace the 1 through 8 and DOT with more human readable / meaningful labels. So I happen to know what each one of these tasks corresponds to. If you're interested where these came from, you can take a look at the research paper. So I'll pull this up now. What I'm going to do is essentially make a dictionary that maps 1 through 8 and DOT to the more interesting or more meaningful label. So let's do that. I'm going to call this task decoder. So remember, a dictionary is an unordered collection of key value pairs. So the key will be how our task is currently encoded, and then its value will be the meaningful string. So task 1 was water plants, and then task 2 was fill medication dispenser. And then task 3 was wash countertop. Four was sweep and dust, so some cleaning activities here. And then 5 was cook. 6 was wash hands. 7 was perform the timed up and go test, which is a standard clinical assessment that's used to essentially determine how long it takes someone to rise from a chair, walk a little bit, turn around, and then sit back down in the chair. And then 8 was the same as 7, but performing tug with questions, meaning while the person is performing the tug test, they're getting out of the chair, they're walking, someone would ask a question such as, what is your birthday? Which is kind of distracting. And it's supposed to test if it takes longer to perform this activity, this task, when there's a distractor. And then lastly, DOT, this stands for day out task. Hopefully my spelling is all good here. Awesome. So let's write a little function called decode task. So it's going to accept a data frame. It's going to grab the task column or the task series from the data frame, and then it's going to go through each key in task decoder, which is a dictionary, right? And we saw earlier this really handy data frame and series method called replace. I'm going to use it again here. So I'll call ser.replace key. So that's a value that we want to replace. We want to replace it with task decoder subkey. So our nice human readable string values up here. And then in place is true so that all these replacements occur in place. I'll call decode task and I'll pass in the data frame. And then I'll print out df.head. And maybe I'll do like the first 10 rows, and we'll see if they've been replaced. So here are the first 10 rows. You can see 1 has been replaced with water plants, 2 with fill medication dispenser, and then all the way down to DOT replaced with day out task. And then for the next participant, participant 1 was replaced with water plants. So this is nice. This makes our data a lot more human readable. The next task we're going to do is we're going to clean class. So if you look at the class attribute, remember we saw that Ultimately, it stores whether a participant was in the healthy older adult group or in the Parkinson's group. But there were a lot of different ways that whoever entered the data used to encode whether they're in group 1, healthy older adult, or group 2, Parkinson's disease. So our goal is to go through and try to converge all of these labels into 2, HOA or PD. So let's write a function to do this. I'll do clean class. It'll accept the data frame. Once again, I'm going to index into the data frame to grab a column, which will be a series. So this will be class. And I'm going to call .copy on this in order to get a copy of this series because I'm going to be modifying the series, right? My goal is, for example, when I encounter underscore HOA, to replace it with uppercase HOA. So let's have a for loop here. For I in range length of ser. So essentially I'm going to walk through each index in the series. The current value, the current class, will be a string representation of series.iloc I. And then I'm going to do a little bit of cleaning right off the bat with this string here, which will be, I'm going to override it with curClass.lower. That way, whether I'm working with uppercase or lowercase, I'm going to normalize all the strings to be lowercase. And then I'm going to do a little bit of checking. So I'm going to say, okay, if HOA is in this class label or healthy is in this class label, then I'm going to overwrite ser at this location with HOA. And I grabbed this healthy label here from the fact that there are some HOA encodings that say healthy. So you'll want to look through and see, okay, what are all the different ways that HOA was encoded? Just like how we saw in the very beginning, there are some that have Parkinson's spelled out. Here's one with capital P Parkinson's. There were some with, oh, here's one that doesn't even have an apostrophe S on the end. And I think there were some with lowercase, right? So we're just trying to kind of write some rules here as if statements that catch all the possibilities for healthy older adult. So let's do the same thing for PD. So if PD is in curClass or Parkinson is in curClass, so writing it this way is going to account for whether there's an apostrophe S on the end or not. And also having this conversion to all lowercase is going to handle when we have an uppercase P and a lowercase p. So we'll converge all of these into capital P, capital D. And then let's see if there's any ones that we missed here. I'll print out unrecognized status. And I will print out the index and then what the class status, the class label is that we're missing here. Now I'll overwrite df subclass with this copy. I might want to say return this copy and then maybe put it into like a cleaned data frame. So a few options here. Let's call this function. And then let's print out, say, the first 5 rows here. We're going to need a few more than that. Let's do, say, the first 15. All right, so it looks like they're all HOA. Let's do the first 25, see if that Parkinson's ended up as PD. Looks good. And it looks like in our output here, we didn't have any else's printing where we had unrecognized status. Checking the first few rows like this, or maybe checking the rows that I knew were problematic in the original data frame or in the original CSV file, is a strategy for checking that we were successful at making sure that we only have PDs and HOAs in all caps in our class column. but it's kind of slow. Also, if we had, say, tens of thousands of rows, we definitely wouldn't want to spot check this manually. So let's actually just print out df subclass dot value counts, and we'll see a series showing the count of each unique value in that series. And so here is our series output right here. So we have 446 HOAs and 219 PDs. There's only 2 entries here, which is awesome, which means there are only 2 unique values in the class column now. So this is now ready for additional analysis, like say doing a group by, where we might group by class to produce 2 data frames, one with only the HOA rows and one with only the PD rows. So we could say compute the average task time for HOA or compute the average task time for PD, and then compare the two, because there's probably a significant difference, right? People with PD probably, as part of my hypothesis based on the research paper, they probably take longer to complete these tasks than HOA, healthy older adults, do. So nice cleaning here. We're ready to do some additional analysis. Now, the last thing that we're going to do, we are so close to being done with this intro to data cleaning demo, is we're just going to check the types of all of our attributes and make sure that our data frame is storing each attribute, aka each column, in the most appropriate type. So here's how I'm going to do this. I am going to iterate through each column, and I'm going to print out the data type of that column. Let's put a label on what we're about to do. Check column types. So I'm going to iterate through each column for column in df.columns, and I'm going to print out the column. So what is the name of the column? And then I'm also going to print out what is the data type of that column in the data frame. So let's see how all of our values are being stored. So participant ID is being stored as an integer, a 64-bit integer, high precision. That's fine. If we wanted to save a little bit of memory, we could probably drop this down to like an int 32. Task, this is being stored as an object. So in Pandas, object generally represents string. So essentially a more specific type couldn't be determined for this column, which makes sense. There were 1, 2, 3, 4, 5, 6, 7, 8, and DOT in this column. So DOT is a string, and 1 through 8 are integers, but because the column had these mixed integer string types, it's just going to say, okay, well, this is all string, right, which is the more generic representation. So task is being stored as an object, which is like string, and then duration is being stored as object. This is actually problematic. I'll come back to this in a moment. And then age is being stored as an int, which is good, and then class is being stored as an object, which is good because that stores strings, HOA or PD. So what's wrong with duration being stored as an object? Well, if we think about duration, it stores an integer number of seconds for how long it took this participant to perform this task. Well, when we originally read in PDHOA activities.csv, there were those question marks in the duration column. So just like how I described that task was read in as object, duration was read in as object because there were mixed types. There were some strings and there were some integers. So Pandas was like, okay, well, these aren't all integers, so therefore I'm going to make this string object. But now we've dropped all of those rows with the question marks. So truly our duration column should be an int, like an int 32 or an int 64, because it doesn't have any missing values. It doesn't have any strings in it. It should be all numeric. And why this is so important is because if duration is stored as object and I try to do some arithmetic with the values in that column, I'm not going to get the results I expect if all of those values are being represented as strings. Let me show you. Let's say I want to print out, let's do the mean of the duration column. So on average, how long did it take all of these participants to complete all of these tasks? So I'll do df sub duration, and then I'll do dot mean, and let's see what happens. Oh no, I get INF, which stands for infinity, right? So this is essentially something that couldn't be computed because we're not working with integer numeric types here, we're working with strings. Let's see what happens if I try to compute the sum. Oh my gosh, I get this really, really huge, what is it? It's actually a string. So let's see if I print the type of this, what we get. There it is, it's a string. Why? because the implementation of the sum method is going to perform binary addition with the plus operator, but this is only binary addition when both operands are integers or floats or numeric types. But if the operands are strings, then plus is string concatenation. So it was concatenating all those strings together. So that's kind of a tricky logic error. It's like, what's going on? So let me save you some time. I showed you how you can detect what the data type is for your column, and now let me show you how you can fix this. So logic error, duration vals are stored as strings when they should be stored as a numeric type. So all we have to do is overwrite df sub duration with df sub duration and then dot as type. And then we do np.int, and we've got a few options for what type of int we do. Let's do an int 32. This is going to take up less space compared to like int 64. There are some limitations though to working with int 32s over int 64s related to missing values or whatnot, but we don't have any missing values, so we're going to keep it simple and just do np.int32. So now let's check the column types again. Now it shows that duration is an int 32, and let's try computing the sum and the mean again. Okay, so now the type of the sum is int 64. Awesome. I'm going to take off that type call. And let's see what these values are. Truly, they should be numeric. And for fun, let's also do standard deviation. There we go. We've got an integer for the sum, which makes sense. We sum up the integers, we get integers. And then we've got a floating point number for the mean and standard deviation. So it looks like on average, it took the participants about 356 seconds to do these tasks. And we've got a pretty high standard deviation here as well. It'd be interesting to do that group by I was talking about earlier and see how these numbers look for the healthy older adults versus the Parkinson's disease. And we can do that now because we cleaned our class column. We are so close to being done here. The final thing that I'm going to do is I am going to write out the cleaned data. Right, we've done a lot of work here to prepare for future analysis, so I'm going to write out this clean data to a new CSV file. I'll call it pd_HOA_activities_clean.csv. So as part of the next step in my data science pipeline, I can just read in that file and immediately start doing like the group by or the aggregation or the visualizations or the data mining or whatever it is I'm going to do next without having to take the time to compute all of this code again. So let's do it. I'm going to do df.toCSV. I'm going to pass in file name. And then I'm going to pass in index is false because I don't want to write out that unique integer 0, 1, 2, 3, 4, etc. index because I didn't have that in my source input file, so I'm not going to put it in my output file. So let's run this for the last time. I'll head over to my file explorer here. I now have pd_HOA_activities_clean.csv. We do not have an index column here. Here are our same 5 attributes or same 5 columns here, but everything is nice and clean. And I'll do a quick check for a question mark, and there shouldn't be one. Fantastic. Well, hopefully you learned a lot in this introduction to data cleaning where we did a hands-on data cleaning demo with some real-world data from a research study. Stay tuned for future data science videos with Python, and hopefully you've got some ideas for how you can apply what you learned here to some projects and data sets of your own. Thanks for watching, and subscribe to my channel for more Python videos.